Hey, this is Christopher. I would like to share with you my final project for my mobile robotics class. In this project, we were tasked with creating a planner, and I chose to create an Dijkstra Planner, and then from that, configure it for a Dijkstra and best first search, and a simple velocity control model. So let me go ahead and launch my simulation here. So to start with, I created this, or used a dynamic reconfigure GUI. Not that one, let's do the right one. So the dynamic reconfigure GUI allows us to change the look ahead horizon so that based on where we are, how fast we move to the next goal point, and then also adjust the parameters for the planning algorithm. So let's go ahead and start with the A-star and place a point. So A-star uses a heuristic based on the cost to come and the cost to go from one point, the goal point, to the end. So because the map is automatically updating, the algorithm doesn't have a global view, and so it creates a local plan based on the current known map in this maze, which is pretty cool. The best first search is a lot less complex. On recalculation, it's not optimal, definitely suboptimal, and then as it computes the goal, a good example is, let me show you something interesting. So the best first search algorithm does not choose the optimal path. If we converted this into the A-star and replace that goal point, come back. Well, yeah, that's already there. It will choose a more optimal path instead of going crazy and all over the place. So another option I have, the complexity is significantly more for the Dijkstra algorithm, as it goes out in waves fronts and does not use a heuristic to march along to determine the best way to go about it. So with the Dijkstra algorithm, there's a little bit more compute time, so we'll do a shorter path, hopefully. Maybe something right, I don't know, it's not that short. Yeah, that wasn't bad. Not bad, Dijkstra. Way to go. Way to go. And there is a vector field control model that I have. I should show you guys this. Where it just goes straight to the path. That actually is utilized with the look ahead point that you see here. It's fairly simple, just plow through things. No detection. It has no planning to it, but it uses an adaptive look ahead point. So let me just plow through something here for you and show you my handy dandy GUI with my adaptive look ahead point can accelerate the speed of the turtlebot or decelerate it adaptively. Whoa, so cool. Anyways, and you can turn it down, which is pretty swell. And let's go back to something interesting like the A-star, because I think it's cool. And if we find a path there, oh, there we go. Oh, I don't know if I mentioned this, but because one thing that I noticed that was there was a large risk of running into corners, and once you hit into a corner, you're now on the other side of the wall. So I provided a region that around the edges of the walls that has a greater weight. And so it has a tendency to push it and kind of do like a wave motion because of the push of the walls. So during like a long straight corridor, there's no problem. It doesn't do that sinusoidal action going on. Let's do another best first search, or right here, because it's so crazy. And it just goes nuts. But, so it's just gonna do best first search, but then if we change this to Dijkstra, please recalculate. It's just way cool. But anyways, that is all for my project. We did quite a few different things for planning the algorithms out. In two different similar situations, the Dijkstra algorithm does some cool stuff versus the, I tried to show you with the best first search. But anyways, thanks.